So anyway, my name is Michael Schloh von Bennewitz, a nice long German name. I live in Munich. I do work there, consult for telecom, small companies, things like email hosting, remote backups, and so on. But I'm pivoting, just like a few other companies in the industry, towards mobile and IoT, connected devices. And so that's what today's talk is about. To imagine how in the future a MINIX-based embedded computer could participate on an IoT network.
Could you use the mic for the audience?
Okay. I'll stand behind the podium, something I really like to do. Okay, so how you doing, guys? Okay, so anyway, right. I actually meant to start on this slide. I don't know how that happened. That's my name. There's my URL down there, and if you want the slides, I will make them available. If they're not online, I have some business cards later. You can come up and get them. So that's what we're going to do in this half hour. We're going to start with some terms and get, just so that we're on the same page, understand what the terminology and the basic concepts of connected devices and IoT is about. We'll take a look at embedded adaptation. Using or abusing some of the fine work that Thomas did, who is in this room. So I'm very happy that he provided so many nice things for our MINIX. Transports and protocols, so we know what's relevant for IoT and what we want to implement if we can. And then some existing things if porting is all what we need to do for servers and brokers from the NetBSD and FreeBSD worlds. Lastly, if we have time, we'll take a look at a typical or an example M2M or a machine-to-machine data flow where messages are passing from one computer to the other. That's what this thing is there in front of us, right? That's an IoT mobile laboratory. So, I guess I should start the timer. So, regarding terminology, there's really no single definition for things for THING, right? Things, and internet is kind of everywhere and nowhere. So what we need to do is at least hammer out a basis for all of this. And these are some of the things that we hear journalists talking about, writing about, usually clueless. They kind of all add up to the same thing in the end. So you have Web of Things, Open Web of Things, if you're hearing from the Mozilla or Firefox, or EFF or Tor, Corner. Internet of Things is kind of a business term. So they're kind of, for our purposes today, it's very similar in meaning. Basically connecting embedded or miniature devices to each other and attaching a human to it, having an interface to that system. There is something interesting coming up from the Google corner. They've kind of come up with a technology which they termed the physical web. This is very specific to beacons and Bluetooth, so we probably don't have time to cover it, unfortunately. Usually within an hour I do. But it means IoT devices turning inanimate objects into IoT devices. So you have a tree, you don't know if you want to cut it down or not, and it gives you a notification because you've placed the Bluetooth beacon on it. Right? That's basically the physical web. And the next thing to understand is that there have been some efforts at defining Internet of Things, or what a thing is that can participate on the Internet and belongs to the IoT term. And it basically means that it's scalable, so we're talking about not thousands, but probably millions and even more devices of this class, so that would be possible. For the architecture, it means it's an autonomous thing, so that means there's no human attached, and it could still work. You know, think of the vacuum cleaner in your home, the modern thing that spins around and knows where the stairs are and so on. It needs to be resilient as well. That means that it can recover from failures easily, and then it needs to be durable. So we're talking about battery operated, but very long lasting. If you hang that thing in a balloon in the air, it's still going to be up there and working in another month. You don't want to change balloon attached computers every few days. It's not practical. So it needs to be durable, and the last thing is obviously it needs to be connected, right? command. So we have stacks of protocols and transports that allow a device or a thing to be connected to another. And just incidentally, what makes this important and interesting to us, do you see any of these things that kind of look familiar from a Minix standpoint? Maybe this one right there, do you think? So this is what makes me interested in unifying Minix and Internet of Things. I think that Minix could take the Internet of Things one step farther in its device architecture, and because it's just so resilient against failure. And we do have some adaptation work on ARM, so we've got battery-operated devices that run Minix, so it's all going in the right direction. So the last thing that maybe we should understand is that there are 3 generic classes of IoT devices. So once we know what belongs to the IoT as a device in general, then we have basically computing nodes, we have sensors, and actuators. Those are the 3 classes. A computing node, I think, is obvious enough. That's whatever thing is in your pocket. It can be a mobile phone, whatever has a processor, right? It could store and forward packets and process, and has memory, and it's a traditional computer. Now, sensors read from their environment. They send this data over some data transport to the computing nodes, which is called telemetry. So if you have a phone in your pocket, it's both a computer and it does have sensors as well, things like proximity and luminosity, microphones, those are all sensors, of course. And then when they do send that over a network, you have a telemetric stream of data. The last thing on the list is an actuator. That's something that lights up or heats the air or spins a rotor, or these are things that are changing the environment, so they're acting on their environment. And when a computing node sends a command to an actuator to change its environment in some way, like a drone that's going to lift off and push air downward, is basically sending a telecommand. So that's the opposite of a telemetry stream. You've got a telecommand stream as well, and that's basically writing to the exterior devices, and the sensors is kind of like reading, if you want to think of it that way. Yeah, so I think the next thing we can do is take a look at Thomas's great work. Where is Thomas anyway? I've actually never met you. He's not here, okay. Well, he's giving a talk in I think 1 hour on device engineering and development, and so I'm going to be there for that one. We're basically going to take a look at the work that he did on I2C and the GPIO system that's running on a BeagleBone, which is this thing here. You see that word there, BeagleBone, and it's got a black color, so this is the BeagleBone Black. Right. Let's take a look at that. We've got there it is. We've got a live running BeagleBone in front of us, right there. And I've prepared this all because with 25 minutes you can't do much, but I've basically got that with a serial connection. Maybe you can see this FTDI cable there. See that I'm wiggling it? So it's basically just a serial connection. So we're going to look at that, and this is a computer here. So we know there's Minix. I think you can trust me on that. And this is a kind of a vanilla image. I flashed this on a SDHC card, and I think I modified very, very little. So I don't think it has a default network that comes up, and these kind of things are also kind of missing, but this is how it looks running on a BeagleBone or ARM-based infrastructure, just the same as anything else. What we're going to do, though, if I can just... so what we're going to do is create a GPIO pseudo file system, and that's the way that we will access the GPIO pins. I'll show you what the GPIO looks like physically. If I can use my finger. You see this row of plastic? Arduinos have this as well, for example. The Arduinos have male pins, so you see the copper, or the brass, or whatever it is, copper, I think. And here they have the female headers. So Yes, there are connections either way, but those are the GPIO pins. They're not every single one of them are GPIO. Some are UARTs and others are power or ground. But that's basically what we're going to manipulate now, and let's do that. So we're in root, and you've seen what's in there. We're going to create something called GPIO and mount. Let's see, let me make sure I get this right. There we go. Let's mount that. And then what we have are a few different things, targets in our pseudofile system. So basically, we're going to check that out. If we read from this one here, what we're asking the system to do is to read from pin 23 in this case. I'm going to connect that now so that we can see. And I'll do this as fast as I can. We're going to connect that to a breadboard, right? And that's a standard battery, the same kind you have in your watch, a 3.3 volt. There are a couple LEDs. Why is that? This thing, I'm going to take this off because that's causing a lot of glare. Okay, so, and now, let's see if I can do this. I'm going to connect pins to the voltage rails. A little electrical engineering here on the fly. That one, so our yellow is a positive. Can't remember the colors, we start with 1. So that's an LED. This one's not plugged in. This is a positive. Put this here. I don't know how well you can see it, probably pretty hard. That finger's in the way. Right, so anyway, basically the thing that we're missing now is power, right? So the LED is there, you can see that. It's just that it's not lighting up because there's no power on there. Now our board is not connected to anything. The board and the BeagleBone are not connected. But I am going to take this battery just to show you how simple this system is, and I'm going to connect that, and we'll see that the LED lights up, right? So I can blink it by turning it on and off. And so the next trick is that we use this battery, and instead of lighting up an LED, I'm going to try to make this write, which is running on the GPIO file system of the Beagle board. I'm going to try to make that turn into a 1. So I'm going to apply voltage to pin 23. How did I guess which pin is 23, right? You can't see it, but from the side, I'll show you the side of that. See that? So I'm cheating. Okay. See that? So the red is positive. I'm just going to connect that to the battery here. This probably will fry my computer, but let's see what happens. So you won't see anything once it's connected, right? So I'm not going to put it on the screen, but I will do this. So what do we have there, right? Now I'm connecting it. I've got to get my fat fingers in there. There it is. There it is. Now do something crazy like this, then we can maybe Okay, so 0, 0, 0. Now we're going to attach and detach. So attaching, detaching. You get the picture, right? Okay, the next trick is to make something light up. So that's going to be fun. You just need to switch from 27. So now we're not going to need battery anymore because the Eagle Bone provides 3.3 volts to its these female headers, the GPIOs that we just saw. They're on the screen. So I just need to get the right rails here. Probably I should be safe and avoid frying something. So that. Attaching ground and aim right. Okay, there it is. Attaching ground and VCC 3.3 volts to those rails, and we should see some LED light up if we get this right. So basically, don't forget, what we have in the GPIO file system are these pseudo, not devices, I don't know what to call them, targets, I guess. And before we were using the write, that was reading from the GPIO, and it was printing a 1 if it had a voltage, and now we're going to write the GPIO. So we're not going to use that one, that target, we're going to use on. And I'll just sleep for 2 seconds so that we have time to switch to the other screen. You ready? Can you count? 1, 2. Oh, you see that? Well, that was not. Let's do it in 3 now. Let's do it in 4. Okay, it's already on. So let's turn it off first. So there we go. And then we can go back and do it again. And that should be clear now. So it turned out. There it is. Have to do some tricks with the screen switching. And then, of course, this is we can turn it off. You think that'll work? Should we try it out? So it's been on from the last experiment. Probably will turn off. Right, hey. And so what a great thing, right? We have been successful in turning an LED on and off. And the thing that I think is okay with this experiment is that it shows you how easy it is to use a basic shell script to connect devices like LCDs, you know, an actuator. It's not anything that has a TCP/IP stack or can run a kernel. But you can connect that to a computing node, which we're doing here with the BeagleBone, which is running Linux. And we've already had a little success with the vanilla image, and we can go off and do more from there. And that's Thomas's work with the GPIO from a couple of years ago. So it would be nice to do more work with that. If I had time, I would, because there's just 2 pins that are working with that. And so what we want to do is have a whole lineup of pins so we can do arrays of LEDs and things like that. Okay, so the next thing on the list, so we took care of that. Right, so that was all basically just applying a voltage. There wasn't a real signal going to that sensor or actuator, but there are quite a few things. This is probably the worst slide of all because there's so much on there. It's really hard to understand. But most of you understand a few things on there, at least the Bluetooth, right? So we've got Bluetooth Smart as a low energy version. That's 4, the 4th version. And then a bunch of other stuff which are relevant for IoT, but not implemented on Minix, and poorly implemented on a few other operating systems. So let's be fair. But AMT, these are all 2.4 gigahertz RF transports. And we've got Zigbee, 802.15.4, or the other way around, 802.15.4. Anyway, Zigbee is interesting because, especially here, because it's not in Amsterdam. I think it's Hilversum, but Philips, wherever they are, They have chosen Zigbee as a transport for their Hue lighting system for buildings, hospitals, homes, and so on. And it works pretty well. And it uses the same spectrum as Bluetooth, but it automatically creates a mesh or a partial mesh network between the nodes, or they look like light bulbs, but they're really computers, right? So we've got all these kinds of things that are relevant for IoT. Obviously, Wi-Fi, it's kind of high power, so not all devices can run TCP/IP stack. Same with copper Ethernet. Z-Wave is another thing. LoRa and Sigfox are low frequency transports, which we'll be hearing a lot more in the near future, I think. In fact, here, who was that? Jan Dongeboom from Telestra. He's doing work here in Amsterdam, and I think Telestra has a LoRa network that anyone living in Amsterdam can connect to. You just need to get a subscription. So that's something very interesting. And those are the transports on this side, right? You can see that these are different. These are protocols. So these things are riding on those. It's kind of a higher level on the networking stack. And I've left out XMPP, HTTP, SNMP, and all these, SIP and so on, the legacy, really heavy-duty protocols, which are good, but they require a lot of battery. So they're not very relevant for IoT embedded systems, not always at least. And they're all just protocols that do similar things. They pass messages to a broker, to a central server, or to one another, P2P. This one is my favorite. It's probably got the most language bindings of all of them, and it's very ubiquitous. There's a few others. This one, for example, AMQP is the one that natively the RabbitMQ server uses. So what my goal is to get some of these servers and brokers running on Minix, right, which we don't have yet. Right, and then H2M, I think I said it before, that means human to machine communication. So that means a person is typing on a screen or looking at something. M2M is a machine to machine communication, like a refrigerator is talking to your garage door opener or something of that sort, as if that makes sense. So what else is there to talk about when we're dealing with transports and protocols? Then we probably want to load some software that can provide us with these services, right? And basically, because the image that is able to run on the BeagleBone or ARM has no package management, like the package-in scripts are kind of empty, or they refer to a binary that doesn't exist. So we need to work on that, I think, if we're going to do stuff with IoT on BeagleBones and Minnow boards and so on. And once we get that finished, we can write these packages. We can compile them for ARM and things like RabbitMQ, Mosquito, which is an MQTT broker, LiveZMQ. They're all available in other repositories like the NetBSD and the FreeBSD ones. The ports just co-op isn't. So unfortunately, we'll have to do some new work to get co-op working. And so this is what I like to finish with. I think we won't have time, but you can all come up and take a look. I'm just going to set it over on the table over there if you want to make a photo or something like that. We'll explain a few things. This is the back of the plastic board, the side that doesn't get me in trouble, because it's just basically a power aggregate, right? It has some power plugs down below and some bricks, and then, well, there's some exceptions. There's a router there, an upstream router, Raspberry Pi that's serving as an MQTT broker, and what else? So there's a LAN tap, so that's how I can tap into an Ethernet connection and study it, read the packets on the wire. Yeah, so this is it's kind of a cool thing. And the new version, this is version less than 1, and version 1 is running right now. The front looks like that, and I think I do have time for one very fast demo. It will be the last thing we do. So let's see what happens if I take this. Firefox OS device. Okay, and go to a website that's running on the Edison, which is a very small computer there. And I will type. I don't know. Can't think of anything normal, so I'll just pick something stupid. Minix is king. So, it's hard to see, isn't it? How can I get that to display better? Right. Okay, so I'm just going to send something to that broker now, and I think we will see something displayed. Exactly. Is that okay? Minix is king? Oh, it went away, but anything I type there will come on the display there. And what I usually like to explain once I do that is the message flow, right? But we don't have time for that. So there's a few different transports and protocols happening, like HTTP that's being proxied to MQTT, and the MQTT is allowing a machine-to-machine communication to take place over copper and then over Wi-Fi and so on, and serial at the end, because the LOL, or the lot of LEDs, the thing that flashes, is mounted to an Arduino, and the Arduino is connected to the rest of the network over a serial connection, a USB connection. That's how it works. Anyway, and that's what we talked about. So I think we're out of time, and I'll just leave it there. I would like to say one thing. I've heard so many awesome ideas today, starting with David and the networking problem and how we can solve that, and then Lazar, I think, was talking about bundling connections, and then with the device management. And it seems that there is some unified areas where there's actually a good plan of attack to move Minix forward. I hope we can arrange and find something to do. So that's all I have. If you have any questions about any of this?
Perfect. Thank you, Steve. Any questions?
So you talked about the number of packages that you want to import on our platform. Is that all? Or do you also need more services, more network facilities? What would you like to see on the system side of Linux? What would help you getting more out of this?
Yeah, so the question is, there was a short list of packages, exotic things that are IoT relevant. If that's really all we need to use Minix with IoT systems, and in my opinion, it's a good start because a lot of the things are quite easy, like a web server. I haven't been able to get one running just for the simple fact that there's no package management and for lack of time. But assuming that the things I didn't talk about are implied, like web service and so on, or web sockets, which are relevant as well for high-powered devices, I think there's a little more to do, but I'm quite impressed that FreeBSD and NetBSD has so much to offer. So I think it could be a slam dunk for about half of this work. I mean, and IoT is kind of a big name in the news headlines. So it could be a good place for Minix to hop on the bandwagon and get some good press. It's just one idea. Yeah.
Any interesting stories from airports?
From what?
Any interesting anecdotes from airports?
Traveling with that device.
Oh, from airports. Yeah, no, I've become a pro at social engineering. So you tell the person what they want to hear, you have to read them, you have to see them from a distance and pick the right door. I mean, I'm a pro at that. I've taken this through 30 airports, right? I've never had problems. Sometimes there are tricks that I have to use when they're really skeptical. Actually, at Schiphol is the only time in my life that they were so skeptical that I was sitting for 10 minutes while they were swabbing and swabbing, and a million euro machine is swabbing the thing 4 times. So what I told them is that there's no active component. So compared to a laptop with a lithium battery full of energy and actually quite powerful and dangerous, this thing cannot do anything until you plug it in. And there's no action, there's no battery, so it's much safer. It just doesn't have a cover, and it's not a laptop, but that's what it is. And then they let me buy it. So it wasn't too bad. Yeah.